Hello students, Sat Sri Akal from my side. How are you all? So myself Indrajeet Singh welcoming you all to the most awesome Let's Improvise. Fantastic. Let's improvise. Fantabulous. Let's improvise. Senseful platform. Again, welcoming you all onto the most senseful platform for the aspirants, those who are preparing for the competitive examinations. So guys, this is the second lecture for the series KVPY. We did a poll. We got an awesome, sensible response. We asked for your requirements. You told us, we fulfilled. Right? So this is the second lecture. Before that, already one lecture related to this has already gone. Units and measurement. You know, already seen. It was very nice to have that awesome response from all of your side. So today we are going to move on with the motion in 1D and 2D. Before some days when I was told that these things I need to introduce, right? We are going to move on with the series because we got an awesome response from the students. Then I was analyzing, right, the previous year's papers of the KVPY. So I got a very surprising conclusion in that. What kind of the conclusion? Guys, in past 7 to 8 years, more than 8 to 10 questions related to this 1D and 2D are already asked. And we are going to discuss all of those stuff, all of those questions in this session with the awesome visualizations. Yes, we are going to discuss. So hope so in midst of the pandemic, you all are well, stay safe, right? Because today class is going to be so much fun with the lots of the visualization, lots of simulations and all of those. And really you are going to enjoy life. So it's my request to be right in this class till end and enjoy each and every moment of this lecture. As we did into the units and measurement, right? The reverse engineering is going on, huh? Reverse. One question is we are introducing in front of you all. We are introducing one question in front of you. I am giving you the specific amount to solve it. Right. After that, if I am giving you some specific amount to solve, right, amount of the time to solve, then after that we are providing you the solution. Now here comes the thing. From that solution, we are analyzing what fundamental concept, right, is used in that specific part, and that will help us to know how this kind of the papers are designed and what are the most important topics, right, relevant, specific for this examination, for this kind of the examinations, right? So as usual, we are going to see more than 20 to 22 questions, the previous year questions for this examination related to motion in 1D and relevant to this topic, right? And from all of those questions, we are going to learn a text. As we did into the last lecture, we are going to learn an awesome text. And it will be really. So are you all ready? I think we should start. Motion in 1D and 2D. Okay. As I said before, physics is entirely depending on two things. Why and suppose. Why? What is the logic behind it? Why this is happening? What is the logic behind it? What is the specific logic behind it? Suppose if things get changed, then what is an alternate solution? Suppose if I am an observer, I am analyzing one activity. First of all, I am trying to think what is the logic behind it. Suppose if things get changed, and what is an alternate solution? So same appears here. The great senseful scientist, right, in field of science and technology, right? He thought, suppose if the head of the entire humanity can be converted in terms of electricity, then we can lighten up the entire world, right? It wasn't the imagination. It wasn't an imagination, right? It was the imagination. It wasn't an imagination because he was the person, right? He was having the ability to convert his imagination into truth. I can't say this might be possible or not, your hate into the electricity, but it was his imagination, right? So let's move on to the relevant topics, right? See, today we are going to deal with the motion of 1D concepts, relevant PYQs, right? Motion in 2D concepts, relevant PYQs, and lots of visualizations. right? Lots of visualizations related to this specific concept. As usual, same procedure we are going to follow. One previous year question one MCQ will come in front of you all. I will give you 1 minute to solve. We are going to discuss that solution and we are going to grab a fundamental concept from that and a new tech to learn. So, are you all ready? Okay, now, before moving on to that specific part, I want to clear you all. This is the part where students get confused. In most of the cases, the student get confused because whenever the kinematic is taught now, first it is taught from 1D perspective and then vectors are introduced. And then suddenly students are drifted to think from the different part, from the another face of the coin. So that is what we can say, the crucial phase, right, for the students, that how things are, because whenever we are saying for the 1D now, right, the downward is taken as a positive, upward is taken as a negative, and suddenly if we are moving on to the 2D and NLM and another part, then suddenly the sign conventions changes, and it has been already told, it completely depends on you what kind of the sign conventions you want to take. There is no, right, what again, there is no, physics is not having any kind of the foundations, no foundations for that. But right, especially for this session, I want to tell you all, we are going to use a very single convention. What is that? Simple. This is a Cartesian, this is an XY plane. Plus I, negative I, two x's I'm talking about, negative j, positive j. Plus I, right? Very simple thing. If vector is directing towards the positive I, we will take it as positive. If vector is directing towards the negative I, we will take it as negative. If vector is directing towards the positive j, we will take it as positive. If vector is directing towards the negative j, we will take it as negative. Very simple. Let us take an example for that. Suppose you are already told that always take g in the downward direction as positive. Now it completely depends on you, but in this session especially, we are going to use this stuff, right? This is an origin. I will consider this as a reference point with respect to this, right? Okay, with respect to this, right? If g is in the downward direction, then it is directing towards the negative j, we will take it as a negative, right? We will take it as a negative. If object is thrown upwards with velocity u, another example, if object is thrown upwards with the velocity u and it is directing upwards, right, towards the positive j, then we are going to take it as a positive. Summarized form, right, I want to tell you all in a very summarized form that downward negative, upward positive, right side positive, left side negative. Especially for this session, right, we are going to use this kind of the sign conventions. Those are easy also, right? Fundamentally, they will help a lot. So are you all ready? So let's move on to the first question of the specific topic. Okay. It has been asked in KVPY 2017. Guys, it is a very, very, very easy question. Some of the students might have started reading this statement and plotted down whatever the data is given. They started, this much amount of the data is given and blah, blah. Because it is easy. It is a very easy concept. I must say it is really very easy. Okay. Now let's move on to that. I will give you a minute to solve and we will see the solution. And we will just grab what is the fundamental concept behind this numerical, what is appearing in front of you. Okay, now let's see. A person goes from point P to point Q covering 1/3 of the distance with the speed 10 km/h. The next 1/3 20 km/h and last 1/3 60 km/h. What is the average speed of the person? A very simple concept. So let's give you all the 1 minute, right? And you can answer this into the comment box, right? And after 1 minute, I will provide you the solution and we'll see the, what we can say, the key concepts of this specific topic. Come on, guys. Okay. Approximately 50 seconds remains a very, very simple formula of the average speed, right? Those who are aware about of the direct formulas, you can just apply. They might have applied. It is very easy, right? When I will explain the solution, I will get it out. Right? Okay, now. Come on, everyone. So less than Okay, less than half time is remaining. Come on, everyone, guys. Okay. 8, 7, 6, 5, 4, 3, 2, 1. Very simple thing, huh? Very simple thing. Let's see. Suppose let us take an example as mentioned into the question. Particle is moving from point P to point Q. The entire path is equally divided into the 3 distance intervals. Suppose the distance between the P and Q is D. The entire D is divided into the 3 equal parts. This is D by 3. Okay. D by 3. D by 3. Now it is mentioned into the question, the first D by 3. The particle is moving with the 10 km per hour speed. Second D by 3, it is moving with the 20 km per hour speed. And third D by 3, it is moving with the speed of 60 km per hour. None of the information regarding the time is given. So it reminds us about the formula of average speed. It reminds us the formula about the average speed. Simple. Total distance by total time. Whoa. Total distance between the P and Q by total time taken by the particle to travel from P to Q. So can I say this average speed, it is having the 3 equal distance intervals. So entire path is formed by 3 intervals, but none of the information is given about the time. So beneath in the denominator, whatever the amount of the time it is there. Let us take an example for D3, D by 3, it is taking T1 amount of the time. For next D by 3, it is taking T2 amount of the time. For next D by 3, it is taking T3 amount of the time. So I am replacing this T as the ratio of D by V. So can I replace it at D by 3 V1 plus D by 3 V2 plus D by 3 V3. D by 3, D by 3, D by 3 all will get cancelled. So final, the average speed I am going to get it as 3 whole divided by 1 by V1 plus 1 by V2, 1 by V3, right? And replacing all of those stuff, that is 1 by 10, 1 by 20, 1 by 60, right? I'm going to get the average speed as 18 km per hour. So whenever the particle travels from P to Q, its average speed is 18 km per hour. So what would be the perfect answer for this specific question? The C will be the perfect answer for this specific question. Everything appears in the visual. For x1 interval, we are having t1 amount of the time. For x2 interval, we are having the t2 amount of the time. For x3 interval, we are having the t3 amount of the time. Now, in this case, right, we got a new concept of, it's not a new concept, it's already been explained into the many lectures and in many batches. So rapidly we are going to grab, right, some important and noteworthy points from this concept data that will be really helpful into the upcoming paper of the KVPY. So first, let us take an example. The same example I am taking, the particle is moving from P to Q. The distance between P and Q is so first, there is a possibility that entire path can be broken into the n number of the possibilities. Particle can go for first time. Let us take an example. For first time interval, particle can go with the speed v1 for time t1. For second, it can be d by 2. See, for suppose first interval is d by n. Second interval is d by 2n. First interval, it is moving with the time v1, with the velocity v1, speed v1 and time t1. For second d by 2n, it is moving with velocity thrice of v1 and time t1 by t2. Anything can happen. So for all of those possibilities, first we are having the general formula of the average speed. In all of those cases, if you are not finding any way, right, you can apply the direct formula, total distance by total time. So here, if the path is broken into the n number of intervals, then we can write this formula as this way. For D1, D2, and this entire path is divided into the n numbers, right? So D1, for D1, the time taken by particle is T1. For D2, time taken by particle is T2. Similarly, for Dn, time taken by the particle is Tn. Right? Time taken by particle is Tn. Right? So this is the simple formula. Now in this, right, you can replace. Suppose if D is not given, then you can replace the upper part as Vt. Suppose T is not given, you can replace the denominator as D by V. Whatever thing you want to do, you can. Now here, after that, we are having the two special cases. What? Suppose if point P and Q, particle is moving on from point P and Q, and it is equally divided into the two parts, D by 2 and D by 2. For first D by 2 interval, particle is moving with speed V1. This is a special case. It is known as equal distance interval. For second D by 2, particle is moving on with the speed of V by V2. Now what will happen? In this case, how to calculate the average speed? So it's very simple, right? None of the, nothing about the time it is mentioned, nothing about the time, no information about the time is given. So for first D by 2, second D by 2, we are replacing it as time. We are replacing the time as a ratio of distance by velocity. So this is D by, as we did into the previous sum. So here we are getting, right, the average speed as 2v1 v2 whole divided by v1 plus v2. So this happens in the case of equal distance intervals. Two equal distance intervals. Two equal distance intervals. Right. Now, another case. Suppose if, let us take a very simple example. Suppose particle is moving from P to Q. Now, for T amount of the time, it is moving with speed V1. For another T amount of the time, it is moving with speed V2. In previous case, we were talking about the equal distance intervals, but in this case, none of the, how the entire path is broken, right? So none of the information is given about it. None of the information is given. So in that case, what we have to do? Simple. The average speed is total distance by total time, right? So here we are going to replace D as a product of V and T. So it will be V1 of T plus V2 of T whole divided by time T plus T. So it will be V1 plus V2 whole divided by 2. This will be the average speed. This will be the average speed. So we are having the three things in front, the three noteworthy points. First, the general formula. Second, the case of the equal distance interval. There is a possibility that entire path can be it can be divided into the three equal intervals, four equal intervals. Same thing we have to apply. D by 4, D by 4, D by 4, D by 4. Like that way you have to move on. So generally we are having the three case, the general formula, the equal distance interval, and equal time interval. Right? Okay. So this was all about the concept of the average speed. Now, let's move on to the next question. Very awesome thing, huh? KVPY 2019, right? I can't say, see, whenever we are going into the examination and whenever we are appearing, right, then always we are thinking that we are having one common issue with all of the students. What is that? Whenever we are seeing 1D, so we are having only 1D perspective in mind. Whenever we are dealing with the kinematics, right, we never consider a force because it states without cause. We accept it. But some good mix or critical thinking, like that kind of the problems sometimes appear in examining the question papers. It appears. It happens. Suppose if I'm talking about this question that has been asked into the 2019 KVPY paper of 2019. If you are reading the statement of the entire question, you will see this thing as from the kinematics perspective. But physics is not all about seeing one thing from that part only. But let's stuck to the point. We are not drifting ourselves. Okay. We have, if you are an observer, question is appearing in front of you. You are an observer, question is appearing in front of you all, right? Then you should have the psychology, what kind of the concepts, you should have that kind of a psychology while solving up the question, that whether whatever I'm doing, I'm correct or not. If this question appears in front of you, right, then you have to just open up whether the force will be included or not. Suppose if we're dealing with the questions of NLM, we never used work energy theorem. But whenever we are dealing with the questions of rotational motion, yes, we are using the work energy theorem. And there exists this kind of question into the examination where it comes up in your mind that yes, this can be solved with the help of the force and acceleration. Then why you applied the conservation of energy? Because they are thinking from all-round perspective, not they are thinking like an all-rounder, nah? They are thinking on the all-rounder types of things. Hope so you understand. So let's analyze this question and we'll move on. A girl drops an apple from the window of a train which is moving in the straight line on the track with the increasing speed at the constant. Girl is moving, no. Train is moving, girl is sitting near the window, she is having apple in her hand. Suddenly, what happens? Right? She ate it. Now she is bored and she wants to throw. Right? She wants to throw and she did it. But at this time, the train is continuously accelerating at a specific rate. The train is continuously accelerating at the specific rate. See, in motion in NCERT is already been taught, nothing is absolute. Nothing is in absolute motion. Nothing is at absolute rest. Completely everything depends on observer. In universe, no one is at rest, no one is in absolute motion. Absolute kind of thing never exists for motion. Everything depends on the perspective. There is a possibility for a person who is standing on the ground, who is analyzing an activity. Oh, train is going. Girl is sitting near the window and she's throwing up the apple. He might be saying something different because he is observer from the ground. And if I'm talking about the girl who is throwing an apple from the window, there is a possibility that she might be saying something different. Observer changes, perspective changes, point of view changes, frame of reference is changing. So my point was, right, to grab you all to the concept of frame of reference. So here the situation is in front of you all. I'm giving you a minute to solve and we'll we will see the solution right after a minute. Come on guys, you all are having a 1 minute to solve this, right? Fast. Less than approximately 34 seconds, sorry. 29, 28 seconds, right? Okay. It's very awesome. Well, less than half time is remaining, right? Because here we are going to intro. See, right now you all are seeing this sum from the 1D perspective, but in the starting, like in the beginning of the session, I already told, right? It is 1D and 2D, right? It is 1D and 2D. Right, so you should have all-rounder. In the cricket, you have heard about all-rounder, right? So here, right, here we have to deal this question like that only. Okay, for that I need to show one visualization. Suppose, see, train is moving like this way. Double quotes, right? This statement should be highlighted. velocity of the train is continuously increasing with a constant rate. It is mentioned into the question and it should be highlighted because answer lies within this statement. Let us take an example. If train is moving in this direction, this is a velocity of train and this velocity is continuously increasing with respect to time. It is continuously increasing with respect to time. Yes, it is continuously increasing with respect to time. Girl is sitting near the window, right? See, here the girl is observer. If the velocity of the train is continuously increasing, right, it means the velocity of the girl is also continuously increasing because she is sitting inside the train. The velocity of the girl is also continuously increasing because she is sitting inside the train. It means that the girl is in a non-inertial frame. So I want to ask you all whether, I want to ask you a very simple thing. If any observer is in non-inertial frame, it means it is an accelerating frame. Will he or she be able to see the reality or what actual thing is going on? No. Reality always lies in inertial frame. Always. If I'm on the ground, yes, I can see all of those, the reality. Right? In the cricket, if the person who is dealing with the bowler, sometimes he might get stuck somewhere or he missed the ball and disastrous result may appear. But the person who is sitting on the as an audience, he might have done something else, so he might get saved. Right? Because he is an inertial observer, na? So things get changed. Right now she is in a non-inertial frame. Non-inertial frame, it is a kind of an accelerating frame. And in this case, right, laws, generally Newton's laws and everything are not applicable. But right now we are not dealing with any kind of the force, but we are dealing with an acceleration. Right? We are not dealing with the force, but we are dealing with the acceleration. So indirectly, right, for non-inertial frame, right, we are dealing with the acceleration. So here Newton's law are not applicable. Really, they are not applicable. So what we have to do, we have to apply the reverse, in the reverse direction of an observer, we have to apply one pseudo force. And there will be one acceleration as because of this pseudo force. Right? When she is throwing up an apple, there will be one acceleration as because of this pseudo force. And again, see, keep one thing in your mind. Observer is girl. Suppose if there is an, as I said before, the observer is in ground. She is saying, oh, girl has thrown up the apple. I can see, right, the actual path of an apple. I can see that. Whatever it should be, it might be the parabolic or anything, whatever it should be. We are not moving on to that part. Right, but I can see, but things are different from that point of view. Things are different from that point, right? And it will appear different for this observer, for a girl. So see, it is accelerating. We are having one force in this direction, so that's why velocity is continuously increasing, right? But being a non-inertial frame, right, the Newton's laws are not applicable, right? And to apply the Newton's law in non-inertial frame, we have to apply the pseudo force into the reverse direction of the motion of the observer. So we applied it, one acceleration into the horizontal direction, it is generated as because of this pseudo force. One is acting into the downward direction. This will be the direction of the net acceleration. This will be the direction of the net acceleration, and this is the thing that will appear for this observer. Inclined path opposite to the train. Inclined path opposite to the train. Inclined path opposite to the train. You can see from her perspective, na, she is, I am moving, right, I am throwing apple. She's like moving like this. No, apple is moving like this way. I'm sorry. Again, I'm repeating. Suppose this train is moving and I'm sitting near the window, right? And I'm having the apple in my hand. Okay. I'm moving on this side and my velocity is continuously increasing through the apple. You can see, na? You can analyze it is moving like this way. Why? Because net acceleration is in this direction. So what will be the correct option? Let's see. A parabolic path in the direction, wrong. A parabolic path, wrong. Inclined, D is a perfect answer for this specific question. See how fundamentally we are moving inertial frame. Till now we have only analyzed, right? Till now we have only analyzed, we are having the two frame of references. One is the inertial frame, second is a non-inertial frame, right? So this was my previous explanation that sometimes some questions in physics may appear, right, that can be solved from both perspective, right? That previous question, right? Okay, no doubt it was a part of 2D, but it needed pseudo force to solve, right? So we can't, the important thing I want to say that we can't bound ourselves that whenever we are dealing with 1D or 2D, right, it doesn't mean we can neglect the force. No, because acceleration, that is a part of the external or whatever net force it is, that it is also playing the important role in kinematics. So we can't, so my main part that I want to deliver, that I want to, what you can say, highlight in front of you all, that we can't neglect in some cases we can't neglect force even in 1D and 2D. We have to. Okay, now let's move on to this question. A particle of mass 2 by 3 kg. This kind of the question is directly, I must say, you can see motion in the straight line, NCERT exercise, right? This kind of the question is already in kind, and has been directly asked into the KVPY examination 2019. Surprisingly, you want to say anything, you want to say or anything, because they are having that kind of the psychology only. They are only they want to check your how strong your fundamental concepts are relevant to physics, how strong you are, how you are analyzing the things from the physics point of view. So this is the thing they are going to analyze. Either it would be for the either those who are designing the papers, right, for JEE, those who are designing the papers for NEET, though whatever it should be, whatever the competitive examination it should be, everything is just checking your fundamental knowledge. Yes, that's the word. They are checking your fundamental knowledge, right? Sorry for my any of the wrong pronunciation. I'm extremely sorry for that, right? Okay. So now let's move on to this question. A particle of mass 2 by 3 kg. Let's note down the data. Mass, it is given as 2 by 3 kg. Okay. Now observer is starting to analyze the motion at t is equal to -2. Generally, we used to start analyze the motion at t is equal to 0. But they are starting, or they are analyzing from t is equal to -2 seconds. At that point, right, velocity of the particle, it is -15 meter per second. See, now here comes force, right? We can't avoid it, right? We can't. We have to be dynamic. We can't be static. Yes, that's a perfect word. We have to be dynamic. So here the force is changing, right? F, that is equal to k minus bt square. Values are given. I'm directly replacing all of those values. 8 minus 2t square. This is how the value of the force is getting changed, right? This is how the value of the force is getting changed, right? Motion is in one dimension. See, force is also given and motion is in one dimension, right? Because they have mentioned, it is their honesty, they have mentioned that motion is in one dimension and we are using force, right? So it is possible. It is possible. We can't bound ourselves, right? Then the speed at which particle acceleration is 0 again. Answer lies in this 3 words. The speed at which particle acceleration is 0 again. This is force. So let's give you all 1 minute to solve and then we will see the solution. It's very nice, huh? Really. Okay, come on everyone, you are having 1 minute in front. Okay, so let's move on to that. Come on everyone guys, it's very easy. Come on. Less than half time is remaining. Come on guys, come on everyone. Okay, so yeah, one dimension and we have to deal with the motion. Okay, see, first of all, I want to tell you all. Force it is given. See, I want to remove, we have seen the two methods related to the motion in a straight line. One, that was when the constant acceleration is there, we were having three equations of the kinematics. With that, we have seen the calculus method also, right? Okay, I will give you the glimpse of that method, but right now, first of all, our main priority is to solve this question. See, force it is given as 8 minus 2t square, right? I'm sorry, force it is given as 8 minus 2t square, right? It is given now. Okay, see, 8 minus 2t square. Okay, 8 minus 2t square. Right now, can I replace this as acceleration is equal to 8 by mass minus 2 by mass into t square? Mass is 2 by 3. 2 by 3, 2 by 3 t square. So here the equation of the acceleration appears at 2, 4, 12 minus 3t square. Right? We reached to the equation of the acceleration from force. We reached successfully. Now, here in the question it was written acceleration is becoming 0 twice. So first we need to calculate at what time interval this kind of thing is happening. So if acceleration is 0, it means 12 is equal to 3t square. So it means we are having the 2 value of t plus or minus 2 seconds. First, acceleration is going to be 0 at minus 2. And it was mentioned into the question what? It is, the motion is about to start and suddenly acceleration appears. So first it happens at minus 2 and second it is going to happen at plus 2. Obviously, acceleration is 12 minus 3t square. It reminds us about the calculus method. I am replacing the acceleration as dv by dt and that is equivalent to 12 minus 3t square. Now, integration of dv is equal to integration of 12 minus 3t square of dt. What will be the limits of this integration? Two intervals are there, na? For time we are having two intervals. First acceleration was 0 at minus 2 seconds. Second acceleration was 0 at plus 2 seconds. At minus 2 seconds, we are given the velocity as 15 meter per second. At plus 2 seconds, when acceleration is again becoming 0, we need to find the v. Integrated v plus 15, that is equivalent to 12 of t. 12 minus 3t square, na it is, right? Okay, okay, 12 minus 3t square, so it is 12t minus t cube, right? Okay, 12t minus, it's t cube by 3 and tt is going to be cancelled, right? And this will be plus 2 and minus 2, right? So this will be v plus 15 is equal to 24 minus 8 minus plus 24 I think something we are going, right? Something, okay. Okay. First of all, I think we need to move on to this part. Just a minute. Acceleration is, okay, acceleration is, let's check it out. Acceleration is, okay. Again, we are going to solve this question. Okay, dv. So dv, that is equal to 12 minus 3t square, right, of dt. Okay, 12 minus 3t square of dt, right? Okay, now integration of dv, as I said before, integration of 12 minus 3t square of dt, right? Okay, so here we are getting 12 of t minus 3t cube by 3, right? Okay, here will be v plus 15, right? And here it would be, here it would be, okay, minus 2 to plus 2, right? Here it would be minus 2 to plus 2. Acceleration is 8 by m, 4 3s are 12 minus 3t square. Okay, 4, yes, exactly. So here v will be equivalent to 15, and that is 12 2s are 24 minus 3 3 is going to cancel 8, right? 24 minus 8, okay, minus plus 24, right? And here again it is going to be, let's, okay, okay, so this will be 24 minus 8 minus 24 minus plus 8, right? So what will happen? V plus 15, that is equal to 24 minus 8 minus 24 plus 8. 24 minus 8, we are going to have 16 plus 16, right? 16 plus 16, and v we are going to have 17 meter per second. This is our perfect answer. Yes, it's okay. That was a small error. We resolved it. Okay. It will be minus 16, minus 16, 16, 32, 32 minus 15. That will be 17 meter per second. Yes, it's perfect. Okay. So it's 17 meter per second. Third will be the perfect answer, right? Now, what will be the analysis for this question? Calculus method, right? For any kind of the motion, this method is very useful. For any kind of the motion, this method is very useful. First, acceleration is always dv by dt. Velocity is always dx by dt, and even acceleration can be defined in terms of v dv by dx, right? So these are the three most important. When this kind of the calculus method is used, whenever one motion parameter depends on another, whenever one motion parameter depends on another. This is a noteworthy point for this specific concept, and it was very, very, very helpful, right? Whenever the one point depends on, right? Like as we have seen into the previous question, right? See, force was depending on time. Like this, it might appear velocity is depending on time, acceleration may depend on velocity, displacement may depend on time. So motion parameters are depending on each other in this kind of the situation, right? Calculus method is a useful tool to reach an answer into the very less amount of the time. Useful tool to reach the answers into the very, 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 very short amount of the time. So kindly mark this statement. You can even take the screenshot for this, right? I'm giving you the 5 seconds for that. 5, 4, 3, 2, 1. Now let's move on to the next question. Okay, this is a very again motion under gravity based question. Okay, asked in KVPY 2018. A ball is thrown upwards at the velocity. Okay, a ball is thrown with a velocity of 45 meter per second in a vertically upward direction. Then what would be the velocity versus appropriate velocity versus height graph? Right? You can select randomly, but there is a fundamental logic behind selecting this answer. There is one fundamental logic, and then I want to discuss with you all. There is one fundamental logic, right? So let's give you a minute to solve and we can reach up to the conclusions, right? Okay. This is the 1 minute. Come on, everyone, those who are live, fast. Okay, less than half time is remaining. Come on, everyone, it's a very simple question. You have to apply one simple formula for motion under gravity. But with one fundamental logic, and that is really going to amaze you. Right? That is really going to amaze you. This is the visual in front, how the ball is thrown upwards with some specific speed. Let us take an example. This is the ground. Right? Particle is thrown upwards with the speed of 45 meter per second. Let us take an example. Slowly, particle is moving upwards and reaching to a specific point of that we are determining it as a max height. It is reaching. So in between point A to point B, you can see here the velocity is completely zero. So in point A and point B, the velocity is continuously decreasing with respect to time. Height is increasing, velocity is continuously decreasing with respect to time. So we are applying, see here, the G is acting into the downward direction and we are having the constant acceleration. This will be T is equal to 0, our reference point. With respect to the reference point and taking the sign conventions into the consideration, we are applying the third equation of the motion as V square minus U square is equal to 2G, right? G will be negative H. Because with respect to the reference point, height is in upward direction, positive. G is in downward direction, that's why negative. U is in upward direction and ultimately it is going to be, right, squared. So here we are getting negative of U square is equal to negative of 2GH, and here the max height that is appearing equivalent to 101 meter, nearly equivalent to 101 point something, but nearly equivalent to 101. Now, if you can see this equation, guys, analyze it. See, H is equal to U square by 2G. 2G is constant, H is directly proportional to U square. If you are seeing this equation, one thing will completely strike in your mind, that yes, the graph will be a curve, not straight line. It means that this option is cancelled, gone. Now, velocity is continuously decreasing, height is continuously increasing. It means that slope of this graph is continuously negative. See, velocity continuously, I'm extremely sorry, velocity is decreasing with respect to height, right? Velocity is decreasing with respect to height. Velocity is decreasing with respect to height. It is decreasing, yes, it is decreasing. It's not a big deal. So it means that slope of graph is continuously negative at all points. Continuously negative at all points. Continuously negative. At all points it is continuously negative. So it means that we can select a graph that is having the continuously negative slope. It is curve. But among these three, this is only the graph that is having the continuously negative slope. See, right? All of those thetas are obtuse. See, all of those thetas are obtuse. Theta obtuse, it means that slope is negative, right? So that is the fundamental logic behind selecting one specific graph. So here the A will be the perfect answer for this specific question. A will be the perfect answer for this specific question. Hope so you all understand this question. It is a very nice, because generally students, right, move up to this much part, right? They used to select and get stuck at this point. But after that, this is an exact logic, right? How to, this will give you the information, what will be the nature of the graph, and the slope will give you the information how graph is moving on from one point to another point. And this visualization will help how it is thrown with 45 meters per second into the upward direction, like this way, right? Like this. Now, if I'm talking about the motion under gravity, rapidly I'm writing down the three equations, right? Because these are only the things that are used. Okay. First, okay, motion under gravity, it means that acceleration into the y direction is g. If I'm talking about our sign conventions, especially for this session, then this is in the downward direction. It means we are considering it as a negative. So if we are considering this as a negative, then equation of the motion can be written as v is equal to u minus gt, right? Or if you want to write a general statement, right, then we can write it down as v is equal to u plus acceleration of y t, right? V square minus u square is equal to 2 acceleration of y into s. Third equation, what? S is equal to u of t plus half acceleration of y. This completely depends on sign conventions, right? Which kind of the sign convention you want to take, right? And how the object is thrown, whether it is thrown upward or whether it is thrown down, right? So this was the sense of the concept motion under gravity. Another concept came. Now we are moving a bit to 2D, because in this KVPY, this awesome question happens. It came and it is really, really nice. I never imagined, right, from the horizontal projectile motion, this thing can appear, right? And I'm really pleased. And whenever you will get this solution for this question, you will also get pleased, because this, right, it deserves. Two balls of mass m and 2m are thrown horizontally with the same initial speed v0 from top of the tower. This is the top of the tower. One object of the mass m. Sir, kinematics and mass, I said before, right? We can't bound ourselves, right? We have to open up to some multiple concepts in this also, in which we have to include mass and force, because in kinematics we are not dealing with the cause, but it doesn't mean everything is happening without cause. There is always a cause, right? It doesn't mean everything is happening without a cause. There is always a cause. There is, right? There is always a cause. Okay. So if drag force is, suppose from a height, m is thrown, 2m is thrown with the same horizontal velocity. The drag force is acting on both with the amount minus kv, where v is an instantaneous velocity of the particle. Now what will happen here? What will happen here? Let's give a minute to solve. Okay. Come on everyone, those who are live fast, you can solve this stuff. Okay, so less than half time remaining. It's a very, right? Generally, whenever the projectile is taught, right, we used to deliver one specific assumption in front of you all. What is that? Never consider any kind of the dissipative forces that is acting on this projectile. We consider air as absent. We consider In another sense, there is no distributive forces acting on it. There is only the presence of gravity. Only gravity. Nothing. No one single gravity. Right. So yeah, let's move on to this concept. See. Suppose, right? Okay. Again. Yes. We got stuck. Okay, we have to select this and okay. Suppose this is the h, right? Height of tower, right? Suppose this is h, height of tower, right? Okay, this is the platform. One particle is of mass m, second particle is of mass 2m. Whenever they are thrown, they will follow some specific trajectory. Right? Whenever they are thrown, they will follow some specific trajectory like this way. At any point on the trajectory, at any specific time between t is equal to 0 and time of flight, I am selecting one position of the particle. Any instantaneous position between the point of projection and where it will hit. Any instantaneous position I am selecting. Right guys? Any instantaneous position I am selecting now. What will happen here? Drag force is acting. It means that drag force will act in both of this direction. On this particle, drag force that is equal to minus kV is acting in this both direction. Suppose if we are selecting this position, so at this point the velocity of the particle is in both direction. Right, this will be the Vy component and this will be the Vx component. One will be the Vy component and second will be the Vx component. Now in this case, what will happen? This drag force will oppose the velocity. It means that one component of the force will act in this direction, right? And one component of the force will act in this direction. Right. Okay, now just remember one thing. Just remember one thing. We can't take the y component of force. Why? No information about the height of the tower is given. There is a possibility that h can be more. The value of the h can be too large. What will happen if the value of the h is too large? If value of h is too large, there is a possibility at any instantaneous position, particle may move with the terminal velocity. Terminal velocity means all forces are balanced, as you have seen in fluids. There is the possibility. H can be less. If it is less, there is a possibility that drag force is acting into the downward direction. Drag force is acting into the downward. But what would happen if value of the h is quite large? A value, as I said, there are chances for the particle to attain terminal velocity, and we don't want that kind of an exception in our concept. So it is good to discard the y component of the force. It means the drag is only affecting the x. Now, drag is only affecting the x, right? The drag is only affecting the x. So it means that suppose if m is thrown, suppose if 2m is thrown, the drag force will act on m and 2m both, but on what object it will act more? On what particle it will act more? Right? Either it will act more on m or 2m, two possibilities. So let's reach to the conclusion, right? Okay, see here it is also given, right? Okay, sorry, not to that specific. It is also given that value of the k is greater than 0, right? Okay, value of k is greater than 0. I'm sorry, we missed it. Okay, so here what will happen? Drag force will, right, drift the particle of the smaller mass m more as compared to the particle having, or you can say the drag force will, right, drift the lighter mass as compared to the heavier mass. So this will be the path of lighter mass and this will be the path of the heavier mass. Here 2m will strike and here m will strike. Okay, as because of the presence of drag force. First is the perfect answer for this specific question. The heavier mass will hit farther from the base as compared to the lighter ball. Heavier will reach farther as compared to the lighter ones, right? So that much fundamentally we are moving, and that I want, right? That quality I want in you all, right? You should all think all of those stuffs, right? Okay, being a dynamic observer, not a static. Mark my words, being a dynamic observer, not static, right? Static. Let's move on to the next question. So nothing. Okay, another question appears. It has been asked in KVPY 2020, and it is really again fundamentally it is really, because already here we have thousands of times. If you have seen many lectures, and everyone is saying G is acting in downward direction, always G is acting into the downward direction, G is acting into the downward direction, but there is something fundamentally we are missing. Something fundamentally we are missing. What is that thing? We are going to analyze in this question. Let's see. A ball is dropped vertically from the height h and it is bouncing elastically on the floor. Elastically. Tung, 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 tung. Same height. This is the height. Like this way. So you are the observer, phenomena is going in front of you, you have to analyze. You are the observer, phenomena is going in front of you, you have to analyze. Right? Which of the following plots best depicts the acceleration of the ball? Which will be the correct acceleration versus time graph? See, figure it is given. Almost it shows the elastic collision. Okay. Let's see. Let's give you all a 1 minute to solve and we'll reach. Okay, this is the minute. Okay, come on. Select the correct acceleration versus time graph. Okay, guys. Now let's see the solution for this specific part. What the question states, a ball is dropped from vertically from the height edge and it is bouncing elastically on the floor. Which of the following plot best depicts the acceleration of the ball as a function of time? See, elastic collision is going on, right? It is a kind of the elastic collision is going on. Ball is dropped from this way. Suppose this is the ground and this is the height. Ball is moving like this way, this way, this way, this way, this way, this way. Elastic collision. Generally what happens? From specific height, ball is thrown like this way, right? It reaches to height h1 and again it bounces. It strikes back to the ground and reaches to height h2. Like this way it's go on. But in this case, it is a case of the elastic collision. So let's see the solution. We are having 4 acceleration versus time graph in front and we have to select the correct one. Okay. So now let's first of all analyze this visual. What is happening? This is happening in front of you all, right? This is happening in front of you all, right? This is what happening in front of you. Now let's see. Suppose this is the ground. This is the height At t is equal to 0, the particle is dropped, right? And we need to plot the correct acceleration versus time graph. We need to plot the correct acceleration versus time graph. Correct. See, whenever the particle is dropped, this will be our point of projection. Let us take an example. At time t, it will hit the ground. Till then, gravity always acts into the downward direction. So it means that suppose particle is starting from t is equal to 0, gravity is acting into the downward direction for what much amount of the time? Till t1 amount of the time, right? Okay, till the amount of the time it will strike to the ground first time. Now, here what the thing lies. Here what the thing lies, right? Okay. So the thing is, most important part, right? So the thing is, from where the ball will again gain the momentum to reach back to the same height. From where again the ball is going to gain the momentum. When it was dropped, it will strike the ground the first time. Till then, G is acting negative. But for a very fraction amount of very small amount of the time, it will impart high momentum to the ball. So the ball again the ball can regain its original height. Very fraction amount of the time. So for that small amount of the time, the acceleration is positive. Again, when the ball will move into the upward direction, G will act into the downward direction. Again, till the time again it strikes back to the ground, the G will be negative. Now the ball is striking second time. So that time also again you have to regain its original height h. So again for a very small amount of the time, my momentum is imparted. So for that fraction of amount of time, the acceleration is positive. Right? Okay. So the graph will be like this way. Right? Graph will be like this way. Right? So yes, B is the perfect answer for this specific question. B is the perfect answer for this specific question. Right? Okay. Now, this was a motion under gravity. Now let's move on to the next question. Whoa. Uniformly accelerated motion and uniformly acceleration and retardation, everything is appearing in this is a very nice and very long and calculative question. Now let's see. A particle starts moving along a line from zero initial velocity and comes to rest after moving a distance d. Particle starts along the straight line, it starts from rest, it ends at rest. 2d by 3, for 2d by 3 amount of the distance, it is continuously accelerated by f, and rest, it is constantly retarded. What we have to see, the time taken by particle to cover the entire distance. It means that, let us take an example, if particle is starting from A, it is reaching to B. It is starting with initial velocity 0, suppose this distance is d. So for 2d by 3 amount of the distance, it is continuously accelerated by f, and after that it is continuously retarded by a. Again it will be reaching back with the velocity 0. Right? So what will be the total time of the journey? That will be total time of the journey, that is t1 plus t2. Let's give you all a minute to solve. Right? Come on everyone. So this is the timer has started. Okay, so less than half time is remaining. It's a very good, it is a bit calculative, right? It is having long calculations, but it is really nice, right, to have this stuff in front of you all, right? It is really, really nice, I must say. Okay. Okay, so time's up. We are going to use the three equations of motions only, but first of all, analyze the visual relevant to the question. See, starting from rest, accelerating, again retarding to be at rest. See the visual, connect it with the question, right? Okay, see the relevant visual and connect it with the question. Starting from rest, accelerating, again decelerating to rest. Three equations of motion we are going to use, but very into different manner, right? Again, I am plotting. This is point A, this is point B, right? This distance is D, 2d by 3, it is moving with the acceleration F, rest d by 3, it is moving with the acceleration A, right? For this, time is T1, for this, time is T2. For one, time is T1, and for next, time is T2. Let's see. Okay, how T1 can be calculated, right? How T1? So for 2d by 3 amount of the time, can we use second equation of the motion, S is equal to ut plus half at square. 2d by 3, that is equivalent to u is 0, right? So directly I can write it as half f T1 square. So here I am getting T1, that is equivalent to, right, 4d by 3f. So T1, that will be equivalent to 2 under root of d by 3f. Consider this as equation number 1. We got this value of T1, right? We have to calculate the total time na, for the journey, that is T1 plus T2. This is the thing we need to calculate. Now we are already done with the calculations of the T1. Now T2 will be quite calculative. Second part. What will be the velocity at the end of the time T1? So that will be, again we are using the first equation of the motion. V will be f of T1. Replacing the value of T1, V will be twice f under root of d by 3f, right? So V will be equivalent to twice, f will move inside, right? So this will be df by 3. This is the velocity at the end of time T1. So here we are getting the velocity as V. Final velocity is 0. Now again we are applying, see, we need to calculate. To calculate the time T2, we need an acceleration. To calculate time T2, we need acceleration. And to calculate acceleration, we need to apply the third equation of the motion for second interval. For second interval, right, can I write 0 square minus V square is equal to, right, what is the distance? 2 into retardation, it means negative d by 3. It is retardation. In a question, this A is given as a retardation. For retardation, we are having the negative sign, right? So here we are having V square is equal to 2 into A into d by 3. Replacing the value of V here, right? What we are getting? We are getting 4, right, into F into D, right, whole divided by 3. That is equal to 2AD by 3. Here we are getting A is equal to 2F. The retardation is twice the acceleration. Time's up. We are having velocity also. We are having retardation also. So again we are applying, moving forward to the fourth step, right? Initial velocity is V. Final velocity is 0. Initial V is equal to U plus AT, right? Simple equation we are going to analyze. V is equal to U plus AT. So this was V, right, and that is equal to A of T2 because A is for retardation negative. So here T2 will, replacing the value, right, we'll get T2 is equal to under root of d by 3f. Replacing the values of V and replacing the values of A, we will get T2 as this equation. Consider this as equation number 2. Now total time is T1 plus T2, so that is 2 under root of d by 3f plus under root of d by 3f, right? So total time that is equal to 3 under root of d by 3f, right? So that is under root of what it will come, 3d by f. This is the total time of journey, right? This is the total time of journey under root of 3 by f. So that much long calculations we are having, right? Okay. The C is the perfect answer for this question, right? Guys, this is a solution. If you want to take screenshot, it's okay. Okay. We have to deal with this kind of, see, some questions are easy, some questions are a bit calculative, some questions are quite conceptual, right? Everything appears. It is a complete package. The physics is completely packaged, a complete package, right? So that's why I kept a visual, a relevant visual related, right? Relevant visual to the concept so that it can be easy to understand. Next question. KVPY 2016, it is very easy question, right? It is very, very, very easy question. I must say it is a very easy question. Okay. Let's move on. A rigid row ball rolls without slipping on the surface as shown into the below. From this position, ball starts rolling and it rolls down the surface. Which of the following is correct representation of the distance versus time graph? The correct representation of the distance versus time graph. The correct representation. Let's have a minute to solve, right? So that we can appear on the conclusion, right? Come on everyone, those who are live, fast, right? Select the correct option for the distance versus time graph. Select the correct option for distance versus time graph. Okay, less than half time is remaining. Okay, see till now whatever the question, whatever amount of the questions we have done, those were from the previous papers only, right? Quite conceptual, right? They force us to think fundamentally, right? And they force us to be dynamic, right? And they force us to be an observer who is an all-rounder, analyzing the activity, analyzing the activity from all perspectives, right? Okay. Okay, see, a rigid ball, see, it's a very simple thing. It rolls like this way. Let us take an example, right? Let us take a very fair example to understand this concept. Okay, suppose the ball is starting from this position A, and reaching to B, crossing from A dash, B dash. Whenever the particle is traveling from A to A dash, now it is moving with a constant velocity. Now, here, the G is acting into the downward direction. Here, the G is acting into the downward direction, and let us take an example. Suppose if this is theta, one component of G will accelerate. This G sine theta, right? It will accelerate the value. If you need an explanation from an energy conservation point of view, then we are having. It is having some amount of the potential energy and it has been converted into the kinetic energy. So velocity at point A dash and B dash is different. At B dash, it will be more as compared to the point at the height. Right? But this is a simple explanation. What? G is acting into the downward direction. One of component of the G will accelerate the velocity of the particle. Again, can I say velocity at the B dash will be greater as compared to the velocity of A dash? Yes, exactly. It will be greater. Now, after moving on to this point, again, the velocity will be constant, but this time with some new value, with different value. So what will be the correct distance versus time graph? What will be the correct distance versus time graph? See, from A to A dash, let us take an example. This is A and this is A dash. Particle is moving with a constant velocity. Yes, it is moving with a constant velocity. No worries. The slope of distance versus time graph, theta is constant. Yes, constant. Suddenly, particle starts accelerating. And at that time, this graph appears like parabolic. When it start accelerating, we can write the displacement equation as d is equal to half t square. So here it is nothing else but a parabolic graph, right? And when the particle is moving with a constant velocity, we are writing equation as v is equal to d by t. When it satisfies the y is equal to mx equation, and this satisfies the equation of parabola. So I'm sorry. Okay. Till the time A dash moving with a constant velocity from A dash to B dash, parabolic graph. From B dash to B, graph will be again the straight line, but this slope will be different as compared to this. Why? Because here velocity was v, here it becomes v dash. Yes, we can understand here it is also performing the uniform motion, and here also it is performing the uniform motion, but the values are different. So that's why the slope of the graph differs. Yes, A is a perfect answer. C, this is a slope theta and this is a slope phi. No, I'm sorry. Parabola is not there. I'm sorry. A is not a perfect answer. Parabola is not there. I'm sorry. Extremely. Okay, no, this is equal. Yes, this one is this is it's not represented that much well. This is theta, right? And this is phi. This is how it appears, right? Yes, this is a perfect answer. It should be like this way, right? And this should be like this way. Angle differs, right? See, angle differs, right? This should be like this way, right? So this is the phi, right? And this is the theta, right? Hope so you are getting all of the concepts, and in between there is a parabolic path. Okay. This question I'm giving you in a homework. Should I solve? It's a very nice question, right? But apart from this, right, we can solve many of the stuff as we can, right? Many of the things we can solve, right? Okay. If you really want to solve this, we can, okay, let's solve this here. It's nice concept. The new fundamental logic. KVPY, it's a question of KVPY, okay, that appeared, okay, in the paper of 2016. A stone thrown down with a speed u takes a time t1 to reach the ground, while another stone thrown upwards from the same point with the same speed take times t2. The maximum height the second stone reaches from the ground is. What is the situation given? Right, very simple. This is height h, right? One stone is thrown downward with the velocity u. Okay, it takes time t1 to reach the ground. Second stone is thrown upward with the same velocity u, right? It takes time t2 to reach the ground. So how much amount of the maximum height the second is taking, right, with respect to the base? This h max we need to calculate. This is h. Okay, let's give you all a minute. Okay, come on everyone. Let's give you all a minute. Okay, approximately less than 50 seconds remaining. Okay, come on everyone, less than 20 seconds remaining. It's a very nice question, and as usual, a bit calculative, right? It's a bit calculative. And then again, we are going to see all of those stuff and long calculation, right? But it is really going to excite us because. Okay, so now let's move on to the solution for this. Okay, suppose, okay, this is a height h, right? One particle is thrown downward with the velocity u. It takes time t1. For first particle, this will be the point of projection t is equal to 0. With respect to this, I am using the second equation of motion. G is acting into the downward direction. So for this, can I say h is in downward, G is in downward, u downward. So according to the sign conventions, negative h, negative u, t1, negative half g t1 square. So for first particle, can I write h is equal to u of t1 plus half g t1 square? Equation number 1. Now for second particle, what will happen for the second particle? See, particle is moving upwards and then coming back down to the ground in time t2. So initial position is t is equal to 0, final position is t is equal to, let us take an example, t2, time of flight. So in between this 2 points, what is the displacement? Because in the second equation of motion, h stands for displacement. In second equation of motion, h stands for displacement. So if we are talking about the displacement h, so in second case also displacement is of h only. There is only one difference. What? H is negative, downward with respect to point of projection. U is upward, so it is positive. Time is t2, g is negative half g t2 square. This is the equation for second particle. Solving 1 and 2, right? Solving 1 and 2, h will get cancelled, right? We are getting u of t1 plus t2, that is equivalent to what? Okay, this will be t1 square minus t2 square. Okay, so this will be g by 2 t2 square minus t1 square. So resolving this, u is equal to t1 plus t2, and that is equal to g by 2, right? t2 minus t1, t2 plus t1. So this is gonna cancel. So we are getting the initial velocity as g by 2, t2 minus t1. Replacing this, we are getting the value of h, right? But we are not in need of that. We can replace this here and we can get the value of h. Okay, let's move on to value of h. H, that will be equivalent to u square by 2g. Using the third equation of motion, because from this position at the max height velocity will be 0, right? So what will be the value of h? That is equivalent to u square by 2g. Wow. G square by 8 into g t2 square, sorry, t2 minus t1 whole square, right? So here h will be g by 8, right? Okay, t2 minus t1 whole square. This is the value of h. Now let's move forward, right? Let's move forward to the another part. Now replacing all of those values into the equation number 1. What is the equation? See, total height h max with respect to ground. We have to find the maximum height attained by the particle to with respect to ground, na? Yes. So that h max will be maximum height attained with respect to, okay, small h plus this capital H, right? So this appears as capital H, capital H, capital H, small h plus capital H. So this will be the h max with respect to ground. Sorry for, okay, h max with respect to ground. This, the max height capital H with respect to the top of the tower plus h height of the tower. So capital H plus small h, the maximum height for the particle 2 with respect to the ground. So H max is equal to small h plus capital H. Now what is the value of this small h? That is equal to, we can replace it as C, capital H. Okay, we got it as a G by 2 T2 minus T1 whole square. We are replacing the value of the small h from this equation, right? That is equal to U T1 plus half G T1 square. Replacing the value of U, so we are getting the H max, right? That is equal to G by 2 T2 minus T1 whole square plus what is the value of U, right? G by 2, sorry, this is G by 8. Okay, G by 8, right? What is the value of U here? That is G by 2, okay, T2 minus T1 into T1 plus half G T1 square. Resolving this, we are getting the maximum height as G by 8, right? T1 plus T2 whole square. Some 2 to 3 steps of calculations are there, right? So we have analyzed the uniformly accelerated motion and motion under gravity from the very different and very easy perspective. No, this is a bit calculative when it appears like this only. What will be the answer? G by 8 T1 plus T2 square, and that is a perfect answer for this specific question. Now here comes the projectile, the special case of the projectile motion. The special case of the projectile motion. Let's analyze this. A projectile is thrown at an angle of 40 degree with the horizontal and its range is R1. So we are not having any kind of the foundations that in a specific amount of the time we need to do 20 sums, we need to do 30 sums. No. But rather than to have a quantitative approach, right, we need to have a qualitative approach. Rather than to have the quantitative approach, we need to have a qualitative. It might be possible the 10th or 12th sum is going on, right, and more than 1.5 hours of the lecture has been completed. But this 10th to 12th sums we have seen from the very different perspectives in the very awesome manner, right? I guarantee, right? So now let's move on to the, see, a projectile is thrown at an angle of 40 degree with horizontal and another at 40. See, two projectiles are thrown. One 40 degree with respect to horizontal, second 40 degree with respect to vertical. The first is having range R1, second is having range R2. So how to identify the relation between R1 and R2? Right, a nice concept is coming in front, a special case of the oblique projectile motion. Let's start. 50 seconds appear in front of you, those who are live. Okay, come on everyone, less than half time is remaining. Okay, less than 5, 4, 3, 2, 1. A very simple explanation for that. Okay, see. This is the ground. One projectile is thrown at 40 degree with respect to horizontal, right? Second projectile is thrown 40 degree with respect to vertical. It means that 50 degree with respect to horizontal. 40 degree with respect to vertical it is given, na? Right? One is having range R1, second is having range R2. Now see, whenever we are having this kind of the relation, you can see 50, 40, 50, 40. Theta 1 plus theta 2 is 90 degree. Whenever this kind of the situation arise, na, right, we are having the specific assumptions for that. First of all, I'm going to solve this question and will give you the sense for this concept. Suppose, what is the formula of range? That is equal to u square sine of 2 theta by g. Right. This is the formula of the range. Sine of 2 theta by g, right? Okay, so here r1 that is equal to u square 2 sine of theta into cos of theta by g. Suppose this is 40 and this is 50. So can I consider theta 1 as theta, theta 2 as 90 minus theta? Is it possible? Theta 1 as theta, theta 2 as 90 minus theta. So r1 will be r square u square 2 sine theta cos of theta by g. Similarly, r2 will be what? U square into 2 sine of 90 minus theta cos of 90 minus theta whole divided by g. Sine of 90 minus theta, right? Cos of 90 minus theta by g. Similar, right? Okay. Sine of 90 minus theta cos of 90 minus theta. So if you can compare this equation, and r1 and r2 are going to be same if they are, say, thrown with the same speed. So this is a special case of the oblique projectile motion, right? This is the special case of the oblique projectile motion if they are thrown with the same speed. Now what is the sense? So here we are getting the answer r1 is equal to r2. The first option is a perfect answer for this specific question, right? Now what is the sense of this concept, right? What is the sense of this concept? Whenever the two projectiles are thrown, one it is thrown at theta, second it is thrown at 90 minus theta, right? If they are having same speeds, three noteworthy points, right? You need to remember, or whatever you want to think, if you want to analyze, you want to understand, okay? Generally you used to understand, but it's okay. Same speed, theta and 90 minus theta range is same. Max height ratio of first particle with respect to the second. The ratio of the maximum height attained by first particle to the second is always equivalent to 10 square theta, right? And the third part, right, the time of flight, ratio of time of flight, that is equivalent to 10 theta. So from now onwards, see, it is this special case has been asked into the oblique projectile or in the KVPY examination. So from now onwards, whenever this kind of the results, whenever this kind of the questions appears in front of you all, whenever this kind of the questions appears in front of you all, right? Okay, so you can directly apply all of those formulas, right? So this is the sense of concept for this question. Now, KVPY 2015, a very nice question appearing in front of you. So this all are the relevant concepts related to 1D and 2D, and they are appearing in front, and they've already been asked into the previous year's papers. So you can understand how fundamentally we are moving on, right? My each and every moment in this lecture is trying to, right, make you all attentive, right, and alert you all about it, that you should be strong in your basics, right? You should all be strong in your basics. So guys, never get bored, please. Never get bored in that, right? You should be all strong in basics, right? This kind of that is okay. Now moving forward to the next question. An object at the rest at the origin begins to move in positive x direction with the uniform acceleration of 1 meter per second square. For first 4 seconds, it moves with the uniform acceleration, and then it starts with the moving with the uniform velocity 4 meter per second in the same direction. Select the correct x versus t graph without wasting the time. I am giving you a minute to solve so we can easily. Come on, everyone. Okay, less than 20 seconds remaining. Come on, everyone, those who are live. 5, 4, 3, 2, 1. Okay, an object at rest, it has an origin. Okay, see now. For first 4 seconds, it is moving with a uniform acceleration. So it is starting from rest, u is equal to 0. For uniform acceleration, s is equal to half at square. S is directly proportional to t square. It means that for first 4 seconds, the graph will be parabolic. Right, it is satisfying the equation. Now you can see y is directly proportional to x square. It is satisfying the equation of parabola. It is satisfying the equation of parabola. Na? It means that for first 4 seconds, the graph is parabolic. So this is s versus t. For first 4 seconds, the graph will be parabolic. Right? For first 4 seconds, the graph will be parabolic. Right? Now, so for parabolic graph will be like this way. Right? Because s is directly proportional to t square. Na? So it is forming mirror image with respect to yc. This is y is directly proportional to x square, right? If you want y square is directly proportional to x, then graph would be like this way. Now, after 4 seconds, it is moving with a constant s velocity. The slope theta is constant, right? So, after 4 seconds, the particle is moving with the constant velocity. After 4 seconds, the particle is moving with the constant velocity. After 4 seconds, the particle is moving with the constant velocity. So what we are having the graph as a straight line, because in that case, right, displacement is directly proportional to t. Right? In that case, displacement is directly proportional to t. Right? So what will be the perfect answer? B will be the perfect answer for this specific question. And here the velocity is continuously increasing with respect to time. That's why we selected this graph. The slope is positive, right? That's why we selected this graph. The slope is completely positive, right? Okay, now let's move forward to the next question. The speed of a body moving with the uniform acceleration is u. This speed is doubled while covering the distance s. When it covers an initial distance s, its speed would be. What is mentioned? Whatever the data is given. Suppose let us take an example. Particle is starting from u. While covering the distance s, its speed becomes 2u. What will be the speed of the particle when it will cover the additional distance s? V. What will be the value of v? So again, let's give you, it's a very simple, it is based on the uniformly accelerated motion, right? Okay, very nice concept, not that much calculative as you are thinking. Immediately it can be solved into 5 to 6 steps, right? Okay, so 1 minute is in front of you all guys. Hope so you are not getting bored. A lot of logical explanations, right, are coming. Okay, it is not like an halla halla and hurre hurre, right? We are trying to impress you. We are really trying to impress you with our content, right? There should be only one perspective that all of in your mind, right? That content. We are trying to impress you. Yes, we are trying to impress you with our content, right? So please try to analyze it. Okay, I must say this amount of the time of the class is worthy, right? It is, yes, it is worth. Okay, time's up guys. So very simple explanation for that. Suppose if it is covering distance s, see this is the reference point t is equal to 0. If we are applying the third equation of the motion between this time interval or between this interval, this distance interval, so can I write v dash? Okay, I'm direct writing the equation, so it will save the time. I'm direct writing 2u whole square final velocity minus u square is equal to 2as. So 3u square is equal to 2as, right? Consider this as equation number 1. We have applied this between 1 and 2. Now, we are applying this between 1 and 3, same. So, if we are applying 1 and 3, so it will be v square minus u square is equal to 2s. S plus s, it will become twice. So, what will happen? Very simple thing. V square minus u square is equal to 4as. If I am replacing the value of as from 3, so it will be 3u square by 2. Right? If I am replacing the value of as, right? If I am replacing the value of as, right, in this equation, okay, so we will get v square is equal to 7u square, right? So v is equal to under root of 7u. The C is the perfect answer. At the end of covering the distance 2s, the velocity, the final velocity of the particle will be under root of 3u. The final velocity of the particle will be under root of 3. Is it clear? Is it clear? Okay, now moving forward to the next question. This question is easy. It has been asked in KVPY 2014. Let's see. In the following displacement versus time graph, at which among the points P, Q and R is the object speed increasing? At what point the speed is increasing? Speed, not velocity. Mark my words. Speed, not velocity. Countdown begins. You are having 1 minute in front. Come on, everyone, those who are live. Okay, less than 10 seconds remaining. Come on, everyone, guys. It's a very simple thing. Okay, very simple thing. In the following, okay, we need to stuck on the slope only. Speed. It's a very common statement. Slope. Sorry, yaar. Slope of x versus t graph shows displacement. Velocity. Slope of x versus t graph shows velocity and magnitude of the velocity shows displacement. Right? X versus t graph, slope shows velocity and magnitude of the velocity shows displacement. Either it can be less than equal, but we can predict it out. Suppose at this point, that theta is acute. Theta is acute. And if we are moving at the top height, theta is becoming 0. So from acute to the topmost point, if we are crossing up the P at point P, we are having some angle, and angle is acute with respect to positive x-axis. But if we are moving on to the top, at the top velocity is 0. It means we are having some amount of the velocity at point P, and at the top it is becoming 0. It means velocity is decreasing. So point P is not the answer. At Q, if we are drawing up the tangent, see it specifically, right? Q and R. If I'm talking about point R, right? I'm drawing up the tangent at the point R, right? What will happen? See, if we are moving forwards to the R now, right, then velocity is increasing in negative direction. If we are following R na, because slope is continuously increasing, just follow the next step of R. Slope is continuously increasing as compared to Q. while moving from Q to R up to this place, slope might change, but not as much high as compared to whatever the changes are noted after the position R. To whatever the changes, those are noted after the position R. So after R, the slope is continuously increasing, velocity is increasing in negative direction, and magnitude of the velocity is speed. It means speed is increasing after R. First is the perfect answer. Speed is increasing after R. The first is the perfect answer for this specific question. So that's why this kind of the questions, the very fundamentally a logical questions comes into the KVPY, and that much fundamentally we have to think. So that's why I said if you want to crack KVPY, right, it's a very, very simple logic. If you want to crack KVPY, it is a very, very, very simple logic. What is that? You have to be fundamentally very strong. You have to be fundamentally very strong. Moving forward to the next question. This is a very easy question. It has been asked into the KVPY 2020. Horizontal projectile motion. The case of horizontal projectile motion, and this is very, very easy. Right, let's see. A mouse jumps off from the 15th floor of the high-rise building and lands 12 meters from the building. Assume that each floor is of 3 meter height. The horizontal speed with which mouse jump is closest to. There are 15 floors. Each floor is of height. How much? 3 meter. So 15 floor, height 45 meter. Mouse jumps from the height of 45 meter. It reaches to the, from the bottom it reaches to the distance of 12 meter. We just need to calculate what is velocity is closest to. 1 minute to the question, and guys, this will be the last question for this today's session, right? Hayana. Okay, 1 second. Okay, the visual of the oblique projectile motion, it is appearing. See, this is how mouse is jumping. This is how mouse is jumping. Right, this height is 45 and this is 12. Right, okay. So the countdown begins here. So we are having the lots of visual, guys. Hope so. It is helping a lot. Right, it is helping a lot. Thanks a lot for your time and the cooperation. You are appearing. You are here. Right. Hope so. As I said before, in each of all of my classes, in all of my sessions, whatever are going live on this platform, as I said, sensible platform, right? Those are helping a lot to be a fundamentally strong, especially in physics. Right? Okay, guys. So as you said, in starting part of the lecture, at the beginning of the lecture, was that much energized. As I said in my previous lecture, from first lecture till end, from first point of the lecture till end point of the lecture, I will be completely energized. Right? Okay. So here 2 and times up. See, very easy question has been asked. Simple horizontal, the range of the horizontal projectile motion as the formula of 2h by g. Right? Range is of 12. We need to calculate u, that is 2. Height is of 45 meter and 10. Right? So 12 is equal to u into 3. We are getting u as 4 meter per second. But options are in kilometer per hour. That much easy it is. Right? So if you want to convert this into the kilometer per hour, that is 4 into 18 by 5, right? So you will get approximately nearly equivalent to 15 kilometer per hour. It is 14.4, but we need a closest value, 15 kilometer per hour. D is a perfect answer for this specific question. D is the perfect answer for this specific question, right? Okay, so guys, I think this is much. Okay. So there appears a homework question for you all. Okay, a lot of questions were there I need to discuss, but it's okay, right? In some else session, don't get so much worried. We'll get the PDF of this, right? We'll get the PDF of this. Okay, so this is the homework question, right? Okay, this is the homework question you need to solve. Okay, you need to solve this homework question. It is a very, very nice question related to 2D motion. Okay. And it has been asked in KVPY 2020 also. See, in the same paper of SA and SX, 4 questions of motion, rectilinear motion, motion in 1D and 2D are there. 2 papers are there na, for SA and SX, right? Hayana. So in SA and SX, 4 questions are appearing. So you can understand the importance of this topic, right? So this is the homework question. You can answer this, right, into the comments below the video, right? Don't get so much worried. It is a PYQ only, okay? So it is not that much impossible to have an answer. Okay, guys. So that's the point. Okay, now Never judge the physics book by its cover. Never judge the physics book by its cover. Never judge it. Physics is sometimes horrible in front of you, but it is if it is represented well, as we are doing, right? Right now, this series is going on. Whenever the new sessions the new batches will come up, right? We will have the live demonstrations also in lecture. We will have the live demonstrations also. Lots of things are going to come. This is our only 1 to 2 lectures. Just follow, be consistent, right? And we are really going to hit the mark. We are going to hit the bullseye, right? Definitely in physics, right? So never judge the physics, right, book by its cover. Maybe it might be horrible, whatever it should be. We are not interested. But yes, on this senseful platform, it is going to appear. It is going to represent in front of you all in the very appropriate manner. Yes, you are going to hit the bullseye, right? So it's time to go, right? Hope so you all enjoyed this lecture, right? So I will be waiting for your awesome comments. Thanks a lot for your cooperation and the lots of the time you are giving to this specific lecture. Thanks a lot. And this is Indrajeet Singh. It's time to sign off from the desk. Bye bye. Sat Sri Akal from my side. Bye everyone. Stay at home, stay healthy, stay safe amidst of the pandemic. Bye everyone.